I think the impetus for all of our studies is trying to understand why some patients progress rapidly and need treatment early, and others can go for a long time and live with just a little bit of treatment here and there. So I think that's the mystery that has motivated so many of us. The approach that we've taken is to use sequencing of the DNA as a way to reveal to us what are mutations, and we look for mutations because we know that is part and parcel of being a malignancy. And the original goal of our studies was to try to understand if there were certain mutations that were positively selected, so not there randomly by chance, but something that was essential, and hence if they were recurrent, that would indicate to us that they were an important part of what makes a CLL a malignant B cell as opposed to a normal B cell. And those studies overall, some of the work, we've done a lot of work in Boston. There have been wonderful colleagues in Spain, in England, worldwide, that have been looking and using the approach of looking at DNA mutations. And thematically, overall, we do find that there's a restricted number of mutations that seem to be quite CLL associated as opposed to other B-cell malignancies. And on the whole, they give us some insight into what are the critical pathways that drive this malignancy. And so I think that becomes important because on one hand, you can identify perhaps different evolutionary trajectories depending on where you started. And on the other hand, you can begin to think about maybe different treatment approaches depending on whether it's a more aggressive or less aggressive phenotype.
Which mutations are we talking about?
Well, that's a complicated question because I think we also have to talk about the evolving treatment landscape of CLL. So up until the last couple years, everyone got chemoimmunotherapy. And we know very well by now through a number of different studies, including our own, that if you study what happens before treatment with chemoimmunotherapy and then at relapse, there are many different genetic changes. We know that TP53 mutation is bad. 17p deletion is bad, and then there's maybe some others as we begin to characterize more that we'll be able to see that there's some that play a relevance in that picture. As we get to the targeted inhibitors, maybe TP53 doesn't play the same relevance. We're still in the early days of looking at that, but I think as we begin to characterize more and more resistance cases, we're going to be able to say more about the mutations that are impactful there.
So we are in the beginnings of the understanding.
We are. I mean, sometimes a common question I get is, are we done with sequencing? So we're about 7 years into it, and yes, we've sequenced a lot of samples, but to make the direct linkages that we care about, which is genotype and phenotype, we're going to need a lot more, and we're going to need to have information that's linked with the clinical history.